Thank you, Omar and Nicholas. And thank you to Cisco for inviting me to come talk at the NSO Developer Days conference. My name is Carl Newell. I'm a network software architect for Internet2. And today I'm going to talk about our automation journey and how we came to Cisco and decided to use NSO for our automation and orchestration needs. Before I dive into our NSO, I want to give you a quick background about Internet2. In the upper right, I work for the Network Services Division for Internet2, where we run a nationwide network in the United States. We have a fiber optic footprint across the country, providing capacity to our members. We are in the midst of upgrading that to from a Sienna 6500 platform to an upgraded Sienna 6500 platform plus wave server transponders. We are also just about to start our packet upgrade, where we're upgrading to 400 gig capabilities across our network on the Cisco 8200 platform. We serve over 300 organizations around the United States, connecting to 100 countries. We have 65 plus regional and state networks. We also provide cloud connectivity to the three major cloud providers, and that's one of our fastest growing services for our members. And we also support the In-Common Federation, where we are one of the stewards for federated identity throughout our organizations. So before I dive into what we're currently doing and how we and what we're going to be doing with NSO, I figured I'd start with our automation journey and how we got here. Internet2 partners with the Indiana University Global NOC for NOC services. They provide service desk support, network engineering support, and systems and software development for Internet2. Around 2011, we worked with them to develop the Open Exchange software suite, commonly called OESS. And this was a software platform for orchestrating layer 2 circuits across the Internet2 network. And this was back when the Internet2 network was running OpenFlow for transport. Fast forward to around 2018, we upgraded OESS to support layer 3 VPN connectivity. And that primary driver was for cloud connectivity for our members. So our members can use our network to provision layer 2 circuits directly into cloud providers. They can also provision layer 3 VPNs, which is a little bit more scalable for many of our members. It also enables inter-cloud connectivity for users that need it. Shortly after that, or around the same time, we were working on automating the rest of our network. So we had a lot of good automation and orchestration in place for circuits on our network. We decided that we needed to uplift the rest of our network to bring it in line. And I think we started where a lot of network shops start, with Git, Ansible, Jinja 2 templates. And we have a system in place, using that, also using AWX Tower. And we currently support about 80% of our configs in that system. It's working really well, but there's challenges on the network engineer side. Introducing network engineers to software development tool sets like Git and Jinja 2. And we're still going through those efforts. Over the past year, we moved on to service model. So looking at services as a whole, so instead of point-in-time configs on individual routers, how do we think about services across our network? So an example is layer 3 VPNs. We don't want to just target individual routers at a time. We want to think about a layer 3 VPN as a service on our network, and model that and configure that across our network. So we worked on developing a service modeling tool, primarily using Yang, and then the automation pieces to push out the appropriate configuration for the network. Sort of in parallel, we've been poking at NSO and trying to figure out what it can do, and we started having this realization that our automation efforts started to look like we were running NSO from scratch, and that really got us going down the path at taking a more serious look at Cisco NSO. During conversations with Nicholas and Guy prior to the conference, Guy had asked me if I had ever heard of the network automation delivery model, which he's going to talk about later today. And I've looked at it, and then he asked if we were following that. And my first response was no. It's interesting, we like it, but we haven't been following it. And then I realized after the fact that we actually had been implicitly following it. We had sort of come across this framework in parallel on our own. And so I just encourage people to go look at the model, see what it can do for them, especially if you're just getting started, see how you can benefit from it, gives you some pointers on how to get started. And even if you're down that path, using it as a reference for further work. So why NSO? I grabbed this slide from one of the many Cisco NSO decks because it really exemplifies why I like Cisco, or why we like Cisco NSO. It's got a great separation between your services and your service models and your devices. We want to think about services on our network. We don't want to think about point-in-time configurations on our devices. And that's what the service modeling provides us. And then that abstracts away the device model and the device configuration from instantiation on the devices. Also, a big one for us is a vendor-supported code base. Instead of writing and maintaining our own code, we have a well-established code base supported by a well-established vendor. Unified network CLI for us is really important. It allows, I think, an easier transition for our network engineers into network automation. They can see a command line that they're used to. Instead of configuring specific configs on the device, they're now configuring those services, and then they can see how those services are going to be pushed out as actual configurations to the devices. NSO also provides atomic commits to our network. So we're now treating our network as a transactional database, and we're mostly assured that when something fails, we don't have to worry about where there's failed config out on the network. It all gets rolled back. And of course, a lot of this is based on industry standards. YANG, NetConf, and RESTConf, and that's important to us due to our the open nature of the Internet2 community and the potential to share some of the YANG models we develop with the rest of our community. Another driving factor towards our decision to go with NSO happened late last year. So around the end of the summer, we put out a proposal for a proof of concept for what we call multi-organization service orchestration. And what we mean by this is can we orchestrate services across individual organizations? So not only within Internet2, but some of our connectors, which are regional networks, then even down into campuses. A lot of our partners provided really good feedback and some proof of concept, but Cisco provided one that we could, immediately made sense to us and that we could dig into. And then one day in November of last year, Mike Kowal from our Cisco account team flew out to Arizona to help me, and we basically put together a proof of concept in a day that looked like this. We had 2 instances of NSO that were what you typically use as your organization's NSO instance that's actually configuring the network, and then an upper layer NSO instance that called down into those 2 instances. And from there, a user could talk to the top level NSO, provision a service like an L3 VPN, make the request, and have that go out and provision the network. Just seeing the ability to build, a skeleton for that out in a day was really appealing to us, and helped our decision to choose Cisco NSO. So now that we made a decision, what are some of the challenges and successes we've had with that? Number one is we are on a team almost entirely composed of network engineers. So we didn't have a lot of software development experience. And we didn't have a lot of experience with NSO. So where do we get started? Luckily, we had the opportunity to build a team. So we put together a team around this, infrastructure, systems, and support. We hired on a director that has decades of software development experience in higher ed to help us with this, Mike Simpson. We borrowed a DevOps engineer from our security team, James Haar. Myself, I'm also on this team, and then IU Global Knock contributed a member that has been developing a primary developer behind OESS, Jonathan Stout, to help in these efforts. So now we had a team. We started figuring out, what to do and how to develop our software development environment. So we had one challenge that we were able to overcome. The next, we're still working through, but I want to highlight it because we see it as an opportunity for us. One issue with any automation system is config drift. What happens if you allow network engineers to log into a device and configure it directly? That config is out of sync with your automation system. What if you have multiple automation systems working on that? They're going to potentially battle for config. So this is a challenge for everybody. But the way Cisco or the way NSO deals with config drift helped us turn this into an opportunity. And we kind of talk about this as an opportunity for a config decision. So if a network engineer is out configuring a service and he's having challenges, he can't do it through NSO. Maybe it's not working or it's not doing it the way he thinks it should. he could still log directly into the device and configure it. Well, now we can look at that after the fact, and we can see that that there's drift, and this alerts us that something's happened. And we can take this up to the architecture team and look at it and decide, was this a valid configuration? If it is, we can now make an architectural decision about our network and decide, that this is valid config. Let's update our architecture. Let's go in and update the NSO model. Along the way, we've had a lot of success with NSO as well. And number one has been from the NSO and Docker efforts from the NSO developers. If you haven't seen this, I encourage you to go take a look at it. It saved us a lot of development time, and we're heavily invested in this infrastructure now. In the beginning, we didn't quite understand how it was put together. I think we had made some missteps, and we've sort of retooled our entire software development about 4 times now. But now it's extremely streamlined. If you're to bring a new developer on board, they need Git and Docker installed, and that's it. They can pull down our repo, run a few make commands, and have a full NSO development environment instantiated on their network with some NetSim devices, and be able to start testing and developing pretty quickly, within minutes. Before I jump into Kubernetes here, one I kind of put up with GitLab. So we also now run all of our environments against GitLab. One reason to do this was because the NSO and Docker developers also use GitLab, and so they already had the CI/CD pipelines built out for this. And we found this to be extremely helpful to get started. So now anytime you check in a branch, it automatically gets built. Pretty soon it automatically gets tested. And now it's also getting deployed to our Kubernetes cluster. For any developer, their branch gets automatically deployed to an NSO instance that has access to a development environment and network environment to start testing their configs. I think the next step there for us is to look at VR NetLab and see how we can instantiate a virtual network for each of the developers according to whatever they need to test their models at that time. And really, all of this revolves around the CI/CD pipeline. And just want to point out that this has been a successful way for us to think about this. We also have a lot of other tools we're building around NSO that are part of this, that are constantly getting built, constantly getting checked in and tested. When I look today, we've kicked off over 400 pipelines just around our NSO instance for development. Again, as I mentioned, we've sort of restarted a bunch of times. So I think just being agile has helped us a lot, and just not being static and not trying to continue down a path to reconsider what we've done, tear it all out and start over. And it's been really helpful. Another thing we talked about with Nicholas and Guy was the NSO community and how important that was to Internet2. And for Internet2, that's very important because we are a community-driven organization, and everything we do is really about our community. So also having a developer community around NSO was important to us, and we found that so far. Between the community forums and Cisco DevNet, there's already answers to a lot of our questions there. It's a great place to post questions, and we get a lot of good feedback. DevNet provides a lot of resources for research and education for us. And as I've already gone into, the NSO and Docker has been a huge uplift for us. The developers behind that are really responsive. They're also responsive to merge requests. It's a fast-moving target, which can be a challenge, but again, they're moving in the right direction, and we're happy to be part of that and in some sense partake in that. And finally, talk about the next steps of what we're doing and what Internet2 is doing. So this is a map of the network. We have over 46 locations across the country where we have layer 2, 3 packet gear. And I like to brag that I think we're in the enviable position of building a greenfield network. So we're actually going to build out our new network in parallel to our existing one, and then code over services. So that gives us an opportunity, to really start from scratch on all of our configs. So we're deploying Cisco 8201s and 8202s across our network. These are the new Cisco platforms based on the Silicon One chipset. They're 400 gig capable, so we'll have 400 gig capabilities across our network. then a couple ASRs and XRVs for route reflectors. And our plan is to do full config modeling across the network. So that's all the configurations and all the services, and have that ready by about May next year to start transitioning services. We'll also be building tooling around NSO and some of our other software suites to aid the engineers in that migration path. And with that, again, I want to thank Cisco for inviting me here. Thank Omar and Nicholas for hosting, and I think we have time for some questions.